All right, let's begin the third installation of trig equations and trig identities. In this section, we're going to focus our work on inverse trig ratios. So we're going to talk about inverse sine, inverse cosine, and possibly even inverse tangent. If you haven't done so already, I'd recommend you pull out your notes on the graphs of inverse sine, inverse cosine, inverse tangent. That's going to be really helpful as we talk about which quadrant the answers are that we're going to be looking for. So first of all, I want to find the exact value of the inverse sine of the square root of 3 over 2. Now what does that really mean? The inverse sine of the square root of 3 over 2. What we're looking for is the angle that has a sine equal to the square root of 3 over 2. If you need to, I'd recommend that you draw the appropriate right triangle. If the angle is going to be the square root of 3 over 2, if the sine of the angle is going to be the square root of 3 over 2, we're going to look in the first quadrant. The sine is going to be this side over here. If that's the square root of 3 over 2, then we've got to be working with a 30, 60, 90 right triangle. This is going to be 60 degrees. Once you convert 60 degrees over to radians, you're going to get that the angle is actually pi over 3, which actually concludes the problem. We now have that the inverse sine of the square root of 3 over 2 is equal to pi over 3. That's it. That's all you need to worry about. So let's make this a little more complicated. I want to find the exact value of the tangent of the inverse sine of 2 over 5. Now, 2/5 is not an angle, or it's not a ratio that we're used to working with when it comes to trigonometry. So what I would first do is rewrite the inverse sine as the sine. We're looking for an angle that has a sine equal to 2/5. Well, the sine of an angle is the opposite over the hypotenuse. So let's go on over and let's draw the triangle. Since the sine is going to be positive, we're going to be working in the first quadrant. Sine of the angle is your opposite, which is 2, divided your hypotenuse is going to be 5. Now, eventually we're going to have to figure out the length of the adjacent side. In order to figure out the length of the adjacent side, we're going to use the Pythagorean theorem. So you're going to have 2 squared plus b squared, let's let b be the adjacent side, equals 5 squared. Which becomes 4 plus b squared equals 25. Subtract 4 from both sides. B squared equals 21. B is the square root of 21. All right, so we've got the appropriate triangle built. Let's wrap this up. We want the tangent of the inverse sine of 2/5. Well, the inverse sine of 2/5 is just your angle theta. If I'm going to find the tangent of theta, the way you find the tangent is it's the opposite over the adjacent. In this problem, the opposite is 2. The adjacent is the square root of 21. So your tangent is 2 over the square root of 21. Since we're not going to be satisfied with an answer that has a radical in the denominator, you multiply the numerator and the denominator by the square root of 21. Final answer becomes 2 square roots of 21 over 21. One more to go. In this problem, we're not going to actually even be given a numerical answer. We're not going to be given a fraction. Instead, we're going to rewrite as an algebraic function of x the expression cosecant of the inverse tangent of x. So just like with the other problems, let's think about what does this inverse tangent really mean. Well, what it means is find the angle that has a tangent equal to x. So again, I'm going to draw my right triangle. If the tangent of angle theta is going to be x, your tangent is the opposite over the adjacent. So let's set it up as x over 1. What we don't know is the length of the hypotenuse, and we're going to need that eventually. So the way we're going to determine the length of the hypotenuse, we're going to use the Pythagorean theorem again. We're going to get 1 squared plus x squared equals c squared. If I want to find c, we're going to take the square root. C equals the square root of x squared plus 1. Now what we're looking for is your cosecant of theta, cosecant of the angle. The cosecant is the hypotenuse over the opposite. So we come over here. There's my angle. The hypotenuse we've already decided is the square root of x squared plus 1. The opposite is x, so our final answer is the square root of x squared plus 1 over x. That's really about as far as I'm going to expect you guys to go with any inverse trigonometric functions. You need to know how to translate the inverse trig over to a statement like the tangent of the angle equals x. You need to know how to draw the appropriate triangle in the correct quadrant. And then from there, it should just be some nice Pythagorean theorem stuff and your basic SOHCAHTOA CHOSHAKEO, and you're going to be done. Good luck. We've got one more section to go. I'll be filming that in just a few minutes.